Could it be true? Another video in the same sentry? Somebody might be running a favor.
Believe it or not, guys, we're back with part 4, and I need you to really listen to what I'm about to say. This is it. Every video so far has led up to this moment, and each lesson has given you like 4 levels, so if you understood the last 3 videos, you're like level 4, 7, 9, 12. This specific video is going to take you from a level 12 noob to a level 100 dungeon ready warrior, the great from the nation of awesomeness. That was completely stupid, but seriously, understanding Multicast and RepNotify is going to open up so many doors for you with multiplayer game development. So far, you've got bits and pieces of concepts, but if you try to put them together, things are still somewhat broke. Well, ladies and gentlemen, crack your knuckles, pour your drink, open up that bag of chips you know you shouldn't be eating right now, and get yourself ready because you're about to level up 88 times. So just before we dive in, I want to let you guys know that the full project is available for download on my GitHub. Just go to github.com/BrianOrtoma and you can download and follow along if you'd like. So make sure you check it out because it's free. I'll put the link underneath the like, the sub, and the ding dong, which also happen to be free. So yeah. Alright, so we're going to review and dive a little bit deeper into how actor replication works and understand the difference between the net load on client and replicates options that are found on the actor. We'll then look at something that we haven't looked at before, variable replication. We'll learn how each replication setting behaves, and that'll give us the foundation we need to properly understand how Multicast and RepNotify work together. We're going to be covering each unique scenario and seeing the advantages and disadvantages of each setting before we get to the final solution that you'll most likely end up using in your multiplayer games. By most likely, I mean like 100% of the time, you're going to be using this in your multiplayer games. This is where you level up. And finally, we'll take a look at what this big black ball is all about, so without further ado, let's dive right in. Let's start off with the net load on client and replicates, and I know, the first thing that comes to your mind right now is, Bri, how are you so handsome? And Bri, what do these two things have to do with one another? Firstly, all credit goes to my mama, and secondly, they're both under the replication section, so you can bet your grandma's ring that they're probably related somehow. As you probably already know, I'm a huge fan of learning from images, patterns, and organized data, so I'm going to tabulate this for you, ooh, fancy word, and then we're going to see why these two settings are extremely related to each other and how powerful they can be if we use them correctly. So when an actor has the net load on client check, the level that this actor is placed in is going to make sure that each client that loads this map also loads their own copy of the actor as well. By default, the setting is turned on, and you'll most likely leave the setting turned on for most, if not all, of your actors. Some of the benefits of the net load on client is that it happens client side and there's no effort or work being done on the server, and nothing pops in and out of existence, especially in large maps, because copies of the actors have already been made for each client's instance of the game. Another benefit is that high-speed moving actors or projectiles travel much smoother because the server is not constantly correcting the position of the actor. There's zero delay when the client is moving their own copy of the actor in their own little world, which means that there's a lot less communication and data being passed from the server to the client, since the server isn't trying to replicate transform data every tick to all connected clients. This, however, leads us to a downside, and that is the client's copy of the actors can easily fall out of sync from the true server version. On the other hand, when the actor has the replicates option selected, it loads the real server version of the actor for each client when the actor becomes relevant to that client. This true copy stays visible by the client until the actor is no longer relevant. If you don't know what network relevancy is, you need to go back and watch part 3 and then you have to come back. Okay? Alright. The benefit of this is that only the true copy is ever visible at any time. There's no risk for client and server falling out of sync because the client will only ever see the server's copy of the actor. Another huge benefit, and the most important one in my opinion, is that we have access to all of the replication related settings that we've been playing with that actually make this actor useful for multiplayer games. The downside is it can be extremely heavy on traffic if there's a ton of actors with a lot of replicated information being replicated to a bunch of clients. And this is especially true if you haven't optimized your network relevancy settings and you're replicating a bunch of actors that none of your players are going to interact with. It is a complete waste of resources. So let's take a look at 3 different scenarios to see how these settings behave when only the replicates option is checked, only the net load on client is checked, and both the replicates and net load on client options are checked. Just a side note, I received some feedback from the last video. I introduced Greeny, Reddy, Bluey, and Yorangy, but Yorangy didn't quite make the cut. I received a couple of messages from people that said they felt slighted and very disappointed that Yorangy was nowhere to be found, so by popular demand, our featured guest today is going to be Pinky. I'm kidding, calm down. Yorangy will be our test dummy today. Welcome to the hood, bro. Okay, so if we open up BP Sphere and go to the viewport, you can see that it's made up of 2 parts, a sphere and another sphere. In the construction script, we've set the second sphere to size based on the net call distance of the actor, which happens to have its net call distance squared set to 50,000. If you have no idea what I just said, that means you didn't listen to me earlier when I said go back and watch part 3 that talks about network relevancy, where all of this stuff is covered in depth. So if you haven't watched it yet, this is the second time I'm telling you, go watch it and then come back. Okay? Alright. In our event graph, we're simply getting a start and end location, slowing down our 1-second timeline by half so it takes 2 seconds to complete, and lerping between the start and end points and repeating this over and over again. Our actor has the net load on client and replicates properties turned off for now because we want these to be our default settings, and what I've done is create 3 child actors of this BP sphere. Actor replicated, actor net load on client, and actor replicated and net load on client. If we open up actor replicated, all of the settings from BP sphere have been inherited since it's the parent. This is inheritance 101. If you don't know what inheritance is, well, that kind of sucks. I'm kidding. That'll be covered in the What Is series whenever it comes out, or you can simply Google programming inheritance and find out right now before the Lord returns. Anyways, I've set each child actor to have a unique setting. Replicates for the red one, net load on client for the green one, and both replicates and net load on client for the blue one. Now if we hit play, you'll see that on the server side, all 3 spheres have loaded and are moving. However, on the client side, there's 2 problems. The first one being that only 2 spheres have loaded, and the other one is that none of them are moving. Let's deal with the first problem, which is not really a problem, it's expected behavior. So when the client loaded the map, both actors that had the net load on client were loaded as well. At first glance, you would assume that when the net load on client option is selected, the actor loads for the clients, otherwise it doesn't load, right? Wrong. If we dig deep into the source code, we can see what's happening under the hood when the net load on client is being used. You need the source version of the engine to be able to dig into this, so for those that are interested, I'll add a link in the documentation that goes into detail on how to download source. For everyone else, you don't need to understand what you're about to see. I just want to show you this because if you're anything like I was terrified of actual code when I first started. The best thing about blueprints and how Unreal has everything set up is that even though you're not touching any code directly, as you learn about the various blueprint nodes and certain game development concepts, you're subconsciously training yourself to understand the code behind the blueprints. Again, if you don't understand any of what you're about to see, it is completely irrelevant and will not stop you from understanding the rest of this video, so don't worry. What will stop you from understanding the rest of this video is if you don't go back and watch part 3 about network. I'm kidding. If we hover over net load on client, you'll see that it says blah 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 map load. What's a map? Unreal refers to them as levels. So if we navigate to UE4, source, runtime, engine, private, you'll see that there's a level.cpp file. Then if we search for net load on client and scroll up a bit, you'll see that it's looping through all the actors in the level, and for each actor, it's checking to see if the code is being run on the client. This B is server is a boolean. That's what the B stands for. It's just a naming convention. The exclamation mark in front of it negates it, so this means if it's not the server, it then checks if the actor's net load on client boolean is not true. If it's not true, aka it's turned off, then call the destroy method on this actor. This destroy method does some checking to make sure it's not already being destroyed and destroys the actor if necessary. Dear Mr. or Mrs. Developer, I just want to thank you for this little gem right here, and I just want to let you know that you made me ruffle my copter. So if we were to create this in blueprints, it would look something like this. Keep in mind, there's no exposed boolean in blueprints named netload on client. I just created a boolean and named it netload on client just for illustrative purposes. I want to help you visualize what this code would look like in blueprints just to show you that it's not as scary as it looks. You may never understand absolutely everything that's going on in here, because I can tell you that I certainly don't, but if you had any fear at all, I hope this little side adventure helps make things a little less scary for you when you think about actual code. Alright, so now we know the red sphere was in fact spawned for the client, but because the net load on client option was set to false, it was destroyed before the client even loaded into the map. However, the server can still see all 3 spheres because if it's a server, we don't care about the net load client option at all. This is why the server is the truth, because it knows everything about everything with the exception of a few things that it doesn't know about or care about that only exists on the client. And don't worry, we're going to dive into what those things are in another lesson. For now, let's make the red sphere relevant to client 1 by placing our viewpoint within the relevancy area, and you'll see that the server is now replicating this actor to the client. If we move our viewpoint outside the relevancy area, once the server does a cleanup, you'll see that it stops replicating and the actor disappears once again. Alright, quote, problem 1, unquote, is now solved, and we even know what's going on under the hood. Problem 2 is actually expected behavior as well. We can clearly see that the actor is in fact replicating because if it wasn't, we couldn't see it when it became relevant to the client. So this red sphere is in fact the same red sphere that exists on the server. However, the movement is not being replicated. If we go into the parent actor, BP sphere, and look at the actor's replication settings, you can probably guess what boolean we need to turn on to replicate movement. I'll give you a hint, it rhymes with replicate movement. No, it's not block input. Come on, guys, have I seriously taught you nothing?
Is it replicate movement, Mr. Brad?
Yes, Timmy, you got it. That is correct.
Since we changed this on the parent actor, all 3 child actors are going to inherit this setting, and if we become relevant to the red sphere again, you'll see that the movement is now replicated. So now that we know how that works, depending on what your actor is, this behavior could be acceptable. If you had a chest, for example, and it was inside of a building, and you didn't want to turn on the net load on client for whatever reason, in your actual game, the network relevancy area would be much higher, so by the time the client got close enough to see it, the server would already be replicating it, and the chest would already be visible to the client. Great, so what if it's not a chest? And what if it's not hidden? And what if it's actually the whole building? Or a bunch of trees? Or the whole sky? What if you have a flat map and the line of sight is ridiculous and you can see across the whole map? If this option is on and it's on by default, then the client will load, and remember, won't destroy it after they load it. So they'll have their own copy of this actor in their instance of the game. So if we walk up to the green sphere, you'll notice that nothing happens even though we're relevant and it's moving on the server. You can see that even the replicate movement is turned on for this actor and still nothing is happening. Notice how I keep saying actors replication settings. Keep that in mind because it's going to become very important here in a sec. Our last example, the blue sphere, has both options turned on. So if we get close enough for relevancy, you'll see that it snaps and instantly syncs up with the server's version. The net load on client is loading the actor so we can see it from anywhere on the map, and the replicates option starts to replicate the server's version of the actor once it is relevant to the client. If we leave the relevancy area, you'll notice that once the server cleans up, the actor stops replicating and just freezes in place. This location in the world was the last piece of information that the server replicated to this client about this actor before replication stopped. If we become relevant again, the server starts replicating the location information to the client, and the client's copy of the actor snaps back in sync with the server's. Don't forget that I've set the net call distance on these actors to a very small number, so in production, you wouldn't get close enough to see any snapping or popping of actors into and out of existence. Alright, so right now you're probably asking, Bri, why do your gorgeous hazel eyes make my knees weak? And Bri, why did you just waste my time with all that useless information? Au contraire, mon ami, it is but a small piece to the magnificent puzzle. Remember how I kept saying actor replication? Let's dissect that a little bit. Notice how all of the settings that we've been playing with so far only show up when we click the actor in the hierarchy. When we turn on actor replication, the actor may be replicating, but that doesn't necessarily mean that everything inside of the actor is being replicated as well. It's important to distinguish the separation between the actor's root replication settings and the replication settings you find in the components or variables that are within the actor. Being able to do so gives us a lot of flexibility when it comes to customization, which in turn gives us the ability to optimize the communication that happens between our server and our clients. So let's take a look at some use cases with variables that are really going to help drive this concept home. So I've created another actor named BP_variable. And over in our viewport, you can really see my artistic side here. Looks just like a variable, doesn't it? We've got a left sphere, a cylinder, and a right sphere. And we also have another sphere that represents our relevancy area again. And then we have some text. In our construction script, I'm creating a dynamic material instance, and I'm setting all three meshes to use that material. Lastly, you've seen this quite a few times now, we're simply just setting the size of our relevancy sphere. In the event graph, there's absolutely nothing happening in this parent actor. So once again, I use this parent actor to create three child actors, and I've named them variable none, variable replicated, and variable RepNotify. And they're all set up somewhat similar. They all have an event timer that executes on the server every second. You may have noticed a node that we haven't used yet. The switch has authority node. When I was a wee little lad and saw this node for the first time, I thought to myself,
Ooh, who's this switch and where can I find this switch that has all the authority? And what's his use?
No.
this is read as switch between what execution pin gets executed based on some condition. If we double click it, you can see that it's just a macro that checks if this code is being run on the server. If so, execute the authority pin, otherwise execute the remote pin. So if we drag off of the remote execution pin and do a print string, you'll see that when we hit play, only the client will say hello. The server continues to run the event timer that updates the float, but you can see on the client, nothing is happening because they never ran the event timer. If we go back and change the print string to only print when we have authority, we'll hit play and only the server will say hello and the client does absolutely nothing. If we remove the switch has authority completely, you'll see that when we hit play, both the server and the client will say hello, which means that both the server and the client are now running the event timer, and notice how they fall out of sync. You'll also notice that none of the numbers are the same because each player is executing their own timer and getting their own random number. This is why you have to run important gameplay logic on the server and then tell the clients what they need to do to sync up their instance of the game with the servers. So knowing that, let's add the switch has authority back in and make sure that only the server can change the variable for this actor. Okay, now that that's out of the way, let's move on to the important piece. If we click on our variable, you can see that under the details panel, there's a replication property. Keep in mind that this replication property on the variable is completely separate from the replication settings on the actor. We talked about this earlier. If we look at the actor settings, we've got the net load on client set just so it doesn't pop in and out of existence, but most importantly, we've got the replicates property set to true on the actor. This is important. Think of this as the master switch. If this is off, nothing about the actor will be replicated regardless of what settings you have set. So if you want anything about the actor or anything inside the actor to replicate, then we have to make sure that this replicates option is set to true. So in this first example, we're setting a non-replicated float variable to a random number between 0 and 10,000, and then we're updating the text to that variable every second. Let's hit play and I'll toggle the widget just so we can see some values, and we can see that the server is updating this float every second and setting the text on the actor as well. Client 1 is not relevant to the actor yet, so when we move into relevancy range, can you guess what happens? Nothing. Nothing's updated, and once again, we're not in sync with the server. Not only is the text not updating, but the client has no clue what the real value of the variable is at all. Okay, so what if we set the variable to replicate? The variable replicated actor has a similar setup, except instead of using a float, we're using a simple boolean that's flippity flopping between true and false every second. Then we set the text to that boolean value. So if we hit play, you'll notice that the server is updating the text every second, but on the client, nothing is happening because we're not relevant yet. We all know this. Once we're relevant, you'll notice, unlike our non-replicated variable, our client now knows the true value of the replicated variable because why?
Is it because it's set to replicated, Mr. Bra?
Yes, Timmy, that is correct.
However, our text is still not being updated. And why do you think that is?
Is it because...
Shut your mouth, Timmy, yes.
If we look at the blueprint, our switch has authority ensures that the client is not doing anything, so only the authority is in fact setting the text. Okay, so what if we plug the remote execution pin to the set text? Well, great, that would work, but only once. Since the client is not running the timer, this isn't going to be repeated over and over again, and we fall out of sync. Okay, so what if we remove the authority switch from up here, so both the client and the server run the timer, but we'll make sure when this update happens, the server has authority will set the variable, and the client simply just updates the text. Since the boolean is being replicated and the client knows the true value, it should update the text properly, right? Let's check it out. So if we move URNG into relevancy, the text starts updating. Yay, no, not so yay, because we saw this earlier. Even though the boolean is replicated and the client is seeing it exactly at the right moment when it changes, it doesn't matter. Since the client spawned after the server pawn did, the timer started at a different time, so the client isn't updating the text at the right moment. Okay, last one. So what if we undo that and just set up an event tick to update the text on the client side? So we'll add an event tick, and since the server is already updating the text for itself every second, we'll add a switch has authority and make sure that only the client is setting the text on tick. And now if we test it, as soon as we get the updated variable, the text is updated. If we fall out of relevancy and wait for the cleanup, then we'll also wait for the boolean to change. As soon as we become relevant again, it instantly updates the variable. Great. Uno problemo though. This is honestly my favorite node on the planet, seriously, because this thing makes or breaks projects. The infamous print string. I'm going to add one of these bad boys right here, and now if we hit play, as soon as we load in, we can see resources being wasted on the client side for running this event tick. I'm not even near the text and the client is trying to set the text. We can fix this by unchecking the net load on client option, and now it'll only start ticking when the actor is relevant to us. Let's test it. Great. So that limits our useless tick to run only when relevant. However, what if the boolean is changing once every 3 seconds, or no longer ever going to change again? This event tick is still running and setting the text to the same thing over and over and over again. Still bad. Also, what if unchecking net load on client wasn't an option because we need to be able to see this from far? And what if there were 10,000 of these? You can quickly see how this method can have a massive impact on performance. So do yourself a favor and try to avoid using event tick when you don't have to. There are certain times where it has to be used, but I've seen this thing be abused so many times simply because it's an easy way to do things and it's the lazy way to do things. You want to try to have your game be event based as much as possible. So if something happens, it makes something else happen, and that makes something else happen. This triggers this triggers the other thing. That way, if nothing is changing or being triggered, your server or client aren't constantly doing something that is redundant or useless, like setting text to be the same thing or setting a door to be open over and over and over again when it's already open. With that in mind, Unreal provides us with a beautiful solution that will help keep this event-based mindset and make everything work nicely without having wasteful logic. In comes RepNotify to save the day. Picture yourself lost in life and you're earnestly seeking the truth. You have 3 family members that have their life together. They're on the right path and know the truth that you seek. One of them is your sister. She knows the truth, but she doesn't want to share it with you. She keeps everything to herself and couldn't care less whether you found your way or not.
Forget you, bro.
Your lives are completely out of sync and on different paths.
Deuces.
The other member is your father. He tells you the truth, but he's pretty strict and that's all he really does. He just gives you the cold hard truth and doesn't really care about whether you find your way back to the right path or not. Then there's your loving and caring mother. Beautiful in every way. She not only tells you the truth, but she gives you directions on how to apply that truth to your life and find your way. The end.
Your sister's a
Hey.
I said gift.
Alright. Anyway, so in our variable RepNotify, we've got a timer that's getting a random vector and setting our linear color variable to that color. For those of you that are curious, a vector gives you 3 values, X, Y, Z, and we're passing those to a color as RGB values, respectively. The color has an alpha, which is set to 1 by default, so this is a quick way to generate a random color. Why does X equal red, Y equal green, and Z equal blue? Because Unreal Engine is beautiful, and if you ever forget which is which, just look at the gizmo. X, red, Y, green, Z, blue. Our variable is set to RepNotify. Now this is similar to replicated, but it has the added bonus of creating a function that gets called when this variable changes for a player. This function is automatically created and prefixed with onRep underscore whatever your variable name is when you set the variable to RepNotify. We can use this function to sync the client back up with the server or get ourselves back on the right path. Thanks, Mom. So whenever my timer updates the color, if any client becomes relevant to this actor and the value that they have stored for this color is different, the server replicates the new value to the client, and this onRep function is triggered and sets the material's color to whatever the variable is. If you're wondering where this material is coming from, it's coming from the parent BP variable actor that we created earlier. You can see all the variables if you click the little eye on the left and click the Show Inherited Variables button. Remember, in the parent construction script, we created a dynamic material instance and stored it in this material variable. I put it under the settings category along with some other variables just to keep things organized, and by showing the inherited variables, I can grab that material and use it in the child actor. Again, this is Inheritance 101. If you don't know what it is, just Google it or wait for the Raptor. Now if we hit play and test, as soon as the actor is relevant to the client, the variable starts to replicate, and thanks to our onRep function, it tells us what the client needs to do in order to keep things in sync with the server. And with that out of the way, I think you're finally ready for the meat and potatoes of this lesson, and if you're a vegetarian or vegan, I guess it would be beyond meat and potatoes, or maybe no potatoes, I don't know. But what I do know is that we've hit the 20-minute mark, so I'm going to kick it up a notch, but you should be able to keep up because you've already seen a lot of this basic functionality and setup of the chest in previous videos. If you need to slow me down, please do so, and if you haven't done so already, feel free to download the project and go through it at your own pace if you feel that I skipped over something. Alright, we ready? Let's get it. So I've created an enumerator and I've called it replication, and it has 4 values, one for each example that we're going to learn about. No replication, multicast, RepNotify, and a combination of both multicast and RepNotify. I've then created a variable in VP chest and I've set it to be of this replication enum type, and I've exposed it and made it editable on spawn so that when we drag a chest onto the map, we can select the type of replication we want to use using a dropdown. This is just an enum though, so please don't mistake the simple selection menu with functionality. The selection menu doesn't do anything at all yet, it's just a way for us to identify the type of chest using text that has meaning instead of just some arbitrary 1234 ID. Inside BP chest, when the toggle open event is called, we switch on this new replication enum type that we've created. Based on the replication type we have set for this chest, we call different events that are going to behave differently based on the type of event that's called. If you still don't know what custom events are, make sure you go watch part 1, 2, or 3 because we use them in every single one of those videos. In the actor's replication settings, we have the net load on client set to true so that we can see them right away and so that the chest doesn't pop in and out of existence when our client goes in and out of relevancy range. We also have the actor's replicates option turned on because without this, like we mentioned before, nothing ever replicates, including the components or variables that are within the actor. Alright, let's follow the logic from scratch. So our player's PP is interacting.
What'd you just say?
Our PP player is interacting when they press their E key, and that calls an RPC or a custom event that is run on the server. The server does a line trace, and if the trace hits BP chest, we call this toggle open event. The toggle open custom event in the chest is set to not replicated. Since our player's line trace is happening on the server and the server is calling this event, this execution remains on the server. So the server call is coming through here, and if we've set the replication type enumerator to no replication, it's going to go up here and call this custom event. This custom event is also set to not replicate, so we're still only running on the server at this point. We could have directly plugged this into our flip-flop, but I wanted to add an extra custom event call just so that we can line things up nicely and use all the colors. But the important piece is this starts on the server and it remains on the server unless otherwise told, and we're not telling it to go anywhere, so it stays running on the server. All this piece does is the same flip-flop we had in the last video. I've just created a function to make things cleaner, and I've added an extra function when it's done opening to turn on and off the emissive just for the extra pizzazz. The only other thing that happens here is if the chest enumerator type is set to multicast and RepNotify, then it does this extra step of flipping a boolean, and we'll get into the details later. For now, let's go look at the first chest. So your RNG walks up to the not replicated chest and interacts, and as expected, nothing happens on the client side. Since the line trace is running on the server and all the events leading up to our function that does the opening of the chest are set to not replicated, everything remains on the server and the server sees it open, but the client does not. That's it. Very simple. Whether your RNG is relevant or not will not make a difference. This chest is not going to open for any clients. Let's move on to the multicast. So once again, this execution line is coming from the server and we're calling MC toggle open. MC toggle open is a custom event with the replicates property set to multicast. Since the server is the one that determines relevancy to an actor and it's the server that's calling this multicast, it not only executes this event on itself, but it also forces any relevant clients to execute this event on their instance of the game as well. So if we get URNG inside the relevancy area and interact, great. The server calls the multicast, I'm relevant, chest opens, everything is dandy. If we're outside the relevancy area and we interact again, the server sees the chest open, but URNG does not. Once we go back into relevancy and interact, we're now out of sync with the server. This is how things break. This begs the question though, what's the point of a multicast if it breaks things when some actors aren't relevant to some clients and their state is changed? Let's pocket this question just for a minute. We're going to take a look at RepNotify and then we'll come back to it, I promise. So if we look at the RepNotify execution path, you'll see that it calls a custom event and this event only happens on the server. And all it's doing is setting the isOpen variable to the opposite of whatever its current value is. Our isOpen variable has its replication type set to RepNotify, so it automatically created the onRepIsOpen function for us. In this function, we're just getting the value of isOpen and setting the rotation of the chest to 130 on the Y if it's open and 0 if it's closed. So if we open the chest when it's relevant to the client, it snaps into open position right away. Notice how if I leave the relevancy area, it still works, but only temporarily. This is the same thing that happens when the actor is replicated. The server takes a few seconds to clean things up after they become non-relevant to the client. Just like our blue ball from earlier, since this actor is still replicating, anything inside the actor is also replicating, including our isOpen variable until it gets cleaned up. This behavior is a little different from how Multicast works. As soon as we were outside the relevancy area, it stopped working without any delay. Think about Multicast as living in the moment and experiencing everything firsthand. You have to be present or relevant to the object in order to experience whatever the event may be. RepNotify, on the other hand, is like a story that you hear after some events have already occurred. You never experience the events firsthand, but whenever you learn about the object or become relevant, you learn about what happened and you're able to get your story straight or sync things back up with the server. It's important to note that the server executes the onRep function on itself as well. If we put in a print string in our onRep function, you'll see that when the chest is open and client 1 is not relevant, it runs on the server. Now, if client 1 shows up sometime later, as soon as the chest is relevant, the server is going to check and see that the value client 1 has for the isOpen variable is different from what the server has. So it replicates the real value to client 1, and when client 1 detects that his variable has changed, he runs the onRep function in his instance of the game and everything syncs up nicely. And now if we interact while we're in relevancy, both the server, who's always relevant to everything, and the client are running the onRep function anytime the server changes the value of the isOpen variable. Great, so now we have a way to trigger one-time events using a multicast, and now we also have a way to sync things up with players that show up later using a RepNotify. So let's put both of these methods together and actually use it in a practical scenario. We're going to need Pinky's help for this one. Me? Oh yeah! So we're going to bring the server over here to oversee everything, and we're going to make sure that Yorangi is relevant but Pinky is not. When Yorangi interacts with the chest, a sound plays, a particle effect appears, and the chest animates to an open position. Only Yorangi saw all of this because the chest was relevant to him when the multicast happened. Pinky didn't see a thing. As far as Pinky is concerned, the chest is still closed. As soon as Pinky becomes relevant to the chest replicates the isOpen variable, and Pinky runs the RepNotify function to open the chest. However, Pinky wasn't there for the multicast that played the sound and the particle effect, which is exactly the behavior we're looking for. So as you can see, if we put everything in the multicast, things fall out of sync if a player misses an event. However, if we put everything in the RepNotify, events that we don't want to happen will happen long after they happened. Does that all make sense? Bottom line is it's important that we use both a multicast and a RepNotify to keep things in sync with the clients and the server. So in conclusion, a multicast is great for one-off events like sounds, explosions, basically anything that you only want to happen once and you only want the players that are relevant to the actor to hear it, see it, feel it, experience it in whatever way possible. And RepNotifies are great for communicating the final state of the actor to players that become relevant after all the multicast events have already happened. And that is it, folks. We have finally made it. And you know what that means?
You have gained 88 levels. You are now level 100 Warrior the Great from the nation of awesomeness Roth. Congratulations, partner.
Hey!
I said developer.
Alright, so the last thing on our agenda is this big black ball up here. I'm kidding, it's nothing special. So we have this sphere that's flying around and its movement is being replicated to the client. If we look at it from the server's point of view, its movement is very smooth. However, on the client side, it may be hard to see in the video, but if you download the project, you'll really notice that it's nowhere near as smooth as the server. If we type t.maxfps1 into our console and we look at the sphere, on the server, it updates every second, but the client, not so much. It's pretty sporadic. Sometimes he gets the update at the same time, other times 3 or 4 frames go by without a single update from the server. This poses a problem when it comes to trying to make moving objects appear smooth on the client side. You may ask, why don't we just send more updates to the client? There's this thing called tick rate, and your server cannot send more updates than its maximum tick rate. So if your server has a tick rate of 30, you can't send more than 30 updates per second to a client. So why don't you jack up the tick rate? Well, it's not that easy. For example, if you've got thousands of actors and hundreds of players connected to your server, more tick rate is really not an option at that point. You're either going to kill your server or kill your wallet, one or the other. We need to be methodical about how we create our game and think about ways we can optimize what our server is communicating to the clients. Remember how I told you to do yourself a favor and try to avoid using things like event tick? That's the kind of mindset we need to be in. Constantly asking ourselves, how can I make this event based? How can I design this so there's little work being done on the server or the client, or the minimum amount of communication happening between them without breaking the game? As an example, our chest demonstration seems to be pretty good, right? Everything is event-based, we have no event ticks or timers at all, and everything is working great. What if I told you we're actually wasting resources with how these chests are set up? When we're relevant, even though this chest is sitting here not doing anything at all, the server is constantly considering this actor for replication. This is unnecessary work that our server does not need to be doing. Unreal provides a network profiler tool that we can use to actually see this information. I've set up a console command that's going to start and stop recording after 3 seconds, so I'll make sure I'm in the relevancy area, and then I'll start recording, I'll open the chest, and I'll wait for the recording to stop. Then we can pull up the session with our network profiler tool, and we can see that the BP chest actor was considered for replication 159 times, and all we did was just open it once and stand there.
Waste.
And that's the end of the series, guys. I hope you enjoyed it. I'm kidding, we can't let this nastiness just sit like that. We need to optimize our actors that just sit there and barely change during a game, and we need to figure out a way to smooth out the movement without sending thousands of updates from the server to the client, especially updates about something like this flying black ball that's completely irrelevant to gameplay. This can all be happening on the client side, so in the next lesson, we're going to take everything that we've learned in this video and optimize the communication between our server and our client. We'll be using the network profiler, which is a very powerful tool. It shows you a ton of information about your actors and what's being communicated back and forth, and it shows you things like RPCs being called, how much replication is going to waste, and so on. So if you're subbed, make sure you hit the ding dong so you don't miss part 5 where we learn about something called the net update frequency. If you're not subbed yet, stop messing around, smash it. If you smashed it and rang it, then you need to break it. If you've done all 3, well then from the bottom of my caring mother's heart as well as my own, I love you. A serious question for all of you though, I'm clearly struggling with keeping these videos short and sweet. They seem to be getting longer and longer, yet my time between releasing them has been getting shorter and shorter, which is a bonus, I guess. I just don't want to show you how to connect pins without explaining the why behind everything. I know some folks don't have the patience to spend 30 or so minutes on one subject and would rather see it be cut up into 4 or 5 shorter videos. I feel like with topics like these, you lose momentum and can easily be distracted with all the cute cat videos that YouTube throws at you at the end of the video. Thankfully though, so far no one has actually complained. In fact, you've all been extremely supportive and I do want to thank you for that. I just want to hear your thoughts on the content length, so please let me know what you prefer. Shorter videos covering a single topic in bite-sized chunks, or longer videos that cover the whole topic separated in a way that makes sense. Please let me know in the comments, and once again, thanks for watching guys, keep being awesome, and I will see you guys in the next video. Brad Diggity Dog signing out. Peace!